let's get started. Today, like I said, we're talking about the composition of gases in the Earth's atmosphere. And just to start, we need to have a definition of the gases in the atmosphere themselves. As you can see here, the atmosphere is just a mixture of gases. Air is not just one gas. If you go to the periodic table, you're not going to see a air element. It's a whole bunch of different gases. And if you were to grab a piece of air here and you compare it to a piece of gas here, it's going to be a little bit different. There's going to be a little bit different composition here than there is over here. Sometimes in certain areas there'll be different gases and near certain areas, and I'm sure you've experienced that in your own life where you're finding different odors and things like that in different areas. That's because the gas is different. The composition of the air is different in that area. And here's a question for you. What do you think are the three most common gases in our atmosphere? And here's a pie chart, give you an idea of the composition of these gases. Here you can see that there's this yellow gas that's quite large. Then the second most gas is quite a bit smaller, and then the third most common gas is significantly smaller from that. That yellow is 78%. What gas is that? Well, pause this if you want to think about it. If not, just go ahead and take a look at the answer on this next slide. It is nitrogen. And here you see nitrogen is abbreviated N2, and that's because nitrogen is a diatomic molecule, and we'll get just sitting here all by itself. What's going to happen is it's going to end up bonding with another nitrogen atom. And that's why nitrogen is abbreviated as N2. And where you'll see this is, like, for example, there are some tire stores, like tire discounters. I know I go there, and they'll fill your tires with nitrogen, and that's why they abbreviate, and it's abbreviated N2. So look for that next time you go to a tire store, like tire discounters. The second most common element, or the second most common gas in our atmosphere, is super important to us, and that would be, that's right, oxygen. And oxygen, again, like nitrogen, is a diatomic molecule, where, again, you're not going to find just one oxygen sitting around, floating around by itself. It's going to bond with something, including another oxygen. And here you're going to see that it is O2. So that's oxygen. And oxygen is approximately about 20% of the Earth's atmosphere, 21%. If you remember, nitrogen is close to 80, and oxygen is close to 20. You're pretty much good to go, because that is significantly the largest proportion of the Earth's atmosphere completely. And then our final, third most common gas is going to range from 0% to 4%. And we're talking about water vapor, and water vapor can be a gas. That's what it means by vapor. Vapor means that it's a substance that normally is in a liquid form or a solid form at room temperature, but in this case it's a gaseous form, so that's why we call it water vapor. So it's water in gas form, and it goes from a range of 0% of the atmosphere to about 4%. You can imagine where it would be 0%, places like deserts. 4%, you might be thinking about maybe a tropical rainforest. Other gases, there's a trace amounts. There's a whole bunch of other gases, argon, helium, things like that, that are going to be in very, very small amounts. That's what it means by trace amounts, a very small amount of gas. You're going to also have some solids up there floating around, dust, just like in your house. You might see some dust floating around in your room. Just like that, you do have solid particles floating around in our atmosphere. And you get a bunch of that stuff up in the atmosphere. It can actually start blocking out the sunlight, maybe even causing temperature drops. Like we talked about, if there's a big volcano, it can throw enough crud up into the atmosphere that it could actually block and shade out the sun and cause even global temperatures to decrease over time. That brings us to something what's called smog. What that is that's going to be a combination of smoke and fog. So smog is going to be like if you're ever near a big factory, or sometimes in big cities, the air is going to be real hazy and polluted. Fortunately, people have gotten a lot better, especially here in the United States. Shoot, when I was a kid in the 70s, I remember cities like Gary, Indiana, places like that, where it looked like a disaster, just like you see here on the screen on this picture. And a lot of smoke and fog and smog. It was very bad. Los Angeles was very well known for having very bad smog, especially due to their large amount of automobiles. Okay, and let's go on a kind of a more cooler, happier note. One of the effects of our atmosphere that's caused by what's called the ionosphere, and we'll talk about that in a little bit, is the Earth has a magnetic field, and you are familiar with that. That's why compasses work. And one of the cool things about the Earth's magnetic field is that it's stronger at the poles, just like a regular magnet, where here's the North Pole, here's the South Pole, and those parts of the Earth are stronger in terms of its magnetic pole. So what's going to happen is you have things called solar wind. You have these particles shooting out from the sun at really high velocity, and they can actually get pulled in and get trapped in the ionosphere at the poles. And it could theoretically happen more towards the equator, but it's the magnetic field is particularly strong at the poles. That's why you're going to see this effect much more often at the very far north or the very far south. And you probably have heard of the northern lights, and the aurora is the lights. Like, for example, really technically the northern lights is called the aurora borealis, and the southern lights are actually southern lights, and those are actually technically called the australis Aurora, I goofed that up. Aurora australis. That'll teach me for not having notes. Aurora australis, and those are that's like the sciencey name for the southern lights. And so you can see it's all caused by the Earth's magnetic field. So if the Earth did not have a magnetic field, like the moon does not have a magnetic field. So the moon is not going to experience this. It's not going to have any, you're not going to have northern lights on the moon.